Good evening and welcome to fellows, members and honoured guests. It's a great pleasure and indeed an honour to address you as the 82nd President of our great institution. It turns out that I've got competition from Harry Styles tonight, who's playing at Wembley. So I guess you're only here because you're not fans of his. I won't assume that you're fans of mine. And thank you to the Royal Society of Chemistry for hosting us in this lovely room tonight. The building is probably most famous as the home of the Royal Academy of Arts, just across the way there. And in looking for a theme for the presentation, that gave me an idea, which you can see on the screen. Is chemical engineering a science or an art? Well, it's a question which I think is worth thinking about. At the moment, your Board of Trustees is working on a new strategy for 2028 and hopefully beyond. And one of the things which we're thinking about is perhaps changing the object of the institution. I'm not going to preview the strategy, and this is just a proposed new wording, but it talks about advancing the art, science, etc., of chemical engineering in all its branches. Now, I think everybody knows what the science is. We've got some great chemical engineering scientists in the room, but what's the art? I mean, is it just a neat bit of process design or a particularly elegant bit of scientific theory? Well, I think it's different to that. I carried out my last chemical engineering calculation probably in 1988. And I still consider myself a chemical engineer. So what have I been doing for the last 30 odd years? Well, I believe I've been practicing what I call the art of chemical engineering, and I'll try and explain that more as we go along. I thought I'd start off right at the very beginning. It's an interesting photograph for three reasons. The first of all, it actually contains the images of 5 IChemE Presidents. You might recognise some. Professor John Davidson, a very eminent member of the academic institution. The late Sir David Harrison, who died earlier on this year, a very great friend. Professor John Perkins, there on the front row, hasn't changed very much. You might find it rather harder to identify a young Professor Stephen Richardson. See, he's shaking his head. Even he doesn't recognise himself. That's him there, and you can tell it's you, Stephen, because I saw you wearing the same cardigan only last week. And last and least of all, that's me over there. If it had been taken a year later, it would have had 6 presidents on it and a president of IChE as well, but that's a snapshot in time. The second reason I show you the photograph is to prove that I once had hair. And thirdly, the total undergraduate class in that year was 13 people. Normally at Cambridge it was 50 to 60. In that year it was 13. And the reason for that was that it was 3 years after the second oil crisis. And students then thought that there was no future in chemical engineering. So nobody wanted to study it. But here we are. We know now that the future for chemical engineering has never been brighter. And I want to try and share some of that enthusiasm with you tonight. I left Cambridge in 1978. It was a time of recession, which is a theme which plays through this presentation. And it was quite tough finding a job. But I joined a company called Landcrow Chemicals in Eccles, which was run by a man called Roger Kingsley. Roger was my great inspiration and indeed mentor for many years. He was president in 1974, and you can see him wearing the same chain of office I wear. I'm humbled to wear before you tonight, and his name's somewhere up here. He was a remarkable man, a German Jew who he was born in the year the IChemE was founded, 1922. His family escaped from the Nazis in 1936 when he was 14. He fought as a commando in the war in Section X. There's some books been recently published about that. And ended up as a captain in Berlin in 1946 before coming back to the UK and taking a first in chemical engineering from UMIST. Well, the other thing is that clearly things were more black and white in 1974, but time moves on. So this is, I can't find, unfortunately, a photograph, a contemporary photograph of the Landcrow site in the 1970s, but the site extended right the way down here on the left, and this road here has been added subsequently. The roundabout, this is the old part of the site. But if you look at, we made quite a variety of chemicals. And if you look, these are actually storage capacities, not inventories, but chlorine, 40 tonnes of ethylene oxide, 250 tonnes of propylene oxide. There were more accidents caused in Germany after the war by ethylene oxide than any other chemical. And before the new chlorine storage facility, this one down here, was built, unloading a chlorine tanker in the middle of the works was quite an interesting experience, to say the least. There were assorted other chemicals I won't bother you with: acrylic acid, SO3, hydrogen peroxide, phosphorus oxychloride. But if you look at the setting, that used to be a hospital, Ladywell Hospital. Before this road was built, there were houses all the way around here. That was the bus station, and that was the market. I can see Ken Rivers over there looking, quietly askance at this. But that's the way things were done as the site developed over the years. And Roger really drummed into all his engineers the importance of taking personal responsibility for process safety, not just for your own benefit, but for the people around it. And that has lived with me all my professional life. Well, just whipping through some of the other career highlights. In the 1980, there was yet another recession, and I moved to South Wales to be engineering manager at a company called Dualite. Roger had moved to become general manager of that. He lived in Paris at the time. And Dualite was, again, quite an interesting company. It made ion exchange resin. One of the chemicals that's used in making anion resin is called chloromethyl ether, which has an unfortunate contaminant in it called bis-chloromethyl ether, which is an extremely potent carcinogen with a ceiling value of 1 part per billion. So containing that and indeed measuring it, if it ever got out, is quite a technical challenge, and that really, excited my interest in containment, which we'll see a bit more about later on. In '84, the company which had bought Landcrow and these other companies, Diamond Shamrock Corporation, an American company, decided it didn't want to be in Europe anymore, and I was made redundant. Now, it was the time of the miners' strike, if you can remember that far back. I lived in South Wales, and things looked grim. However, a job offer in the form of operations director of an activated carbon company, Sutcliffe Speakman Carbons, duly arrived, and you won't be surprised to find that, or to hear that, Roger was a non-executive director there. I had a number of, we had 2 international sites, one in Sri Lanka and one in the Philippines, which I had some technical responsibility for. There was a war going on in both places at the time, so overseas postings are not necessarily a very good thing. But I fell out with the main board over a concern I had about process safety, believe it or not. And in 1987, Roger, again, introduced me to John Freeman in his one-man nascent process engineering business, which is where I've spent effectively the rest of my career. We did very well in the early years. We went from 2 people to 140. And we invited Roger to become our first chairman, which was, some good and some bad in that, because he had great ambitions for us. And in 1990, we bought a company from Cranfield University called Cranfield Engineering and Technology Enterprise. And I'm delighted to see Professor Phil Hutchinson from Cranfield in the audience tonight, who was our non-executive director. It was a very high-end mechanical and electronics consultancy, almost the consultant's consultant, if you like. But by early 1992, there was yet another recession. And before quantitative easing had been invented, what happened was the bank manager knocked at the door and asked for his overdraft back. We had a modest overdraft of £40,000. We wanted to increase it to 50, and he said, no, I'd rather have it back. So we orchestrated a fire sale, I suppose it was really, to Hayden McClellan Holdings, which was a $1 billion at the time turnover British conglomerate, primarily in the automotive industry. And that was interesting in that I learned a lot about the risks of bad project management and bad company management in that time there. They had a worldwide business, a big facilities management business in Australia, but the main activity was building paint shops for spraying cars as they were on the production line. David talked a bit about ethics earlier on. If you want to find an industry which values ethics perhaps a little bit lower than we do, try the car industry. The contract terms are so disadvantageous towards the contractor. I'm surprised anybody exists in that, and quite a lot of the contractors who, including Hayden, have gone bust over that. But they got into 2 large contracts at the same time, £100 million contracts, which were going badly wrong, and the whole thing collapsed. Every cloud has a silver lining, and I was able to buy back what was then Hayden Freeman in 1999, and the rest, as they say, is history. People talk about a public school education being expensive. I'll tell you, it's not as expensive as working for a company who gets its management wrong. And the same, the bank manager came to them and wanted its overdraft back, and they couldn't manage it. So moving on, Hayden Freeman started off as a specialist consultant and contractor, initially operating in fine chemicals, then pharmaceuticals, then recycling and environment management industries, very successful. The problem with any contracting business is the cash flows are either fantastic or terrible, highly cyclical. In 2001, we formed HFL Risk Services in a response to the new Control of Major Accident Hazards legislation. Again, legislation is always good for consultants, and we had a fantastic business helping people write coma reports based on our deep knowledge of how chemical plants should operate. Around about the same time, we formed a franchise for an American company selling modular pilot plants, very popular at the time in the pharmaceutical industry. We sold 6 to AstraZeneca in 1 year. It was fantastic. And in 2004, the opportunity to purchase a much bigger competitor, Buwelco, arose, which is what we did. Buwelco were big in flare tips, fired heaters, and general engineering contracting. It was interestingly, it was reported in the Chemical Engineer that this was a £9 billion takeover, which did my ego wonders because the group was funded entirely out of my own pocket at this time, and it was out by quite a few zeros, but it made me feel great about myself. The problem with the Buwelco business was quite similar to the Hayden paint shop business in that the contract terms for these big projects, I mean, each of these heaters here is £20 million. The flare tips are a few £100,000, but they were mostly used in the offshore industry. The trade name was Sonajet. The secret's in the name. They were a bit limited to where you could use them because when they ignited, they produced a sonic boom, which was not very conducive to selling them on land use. But we carried on. We found a business model that worked for us, doing refurbishments, selling spare parts. And again, we managed with an untouched overdraft facility because I had this paranoia about the bank manager knocking on the door. So in 2005, we bought the Process Industry Centre for Manufacturing Excellence, a consultancy set up by the DTI, operated by the Chemical Industries Association, and that took us into lean consultancy and a very interesting and profitable area. And we sold that service to many people, and I'm a great fan of lean. And in 2006, we recruited a senior executive from a facilities management company to form HFL Building Solutions, which looks after a lot of high-spec buildings across England, from the borders down to London. And really, that was an idea I got from Hayden McClelland. The best bit of their business was the facilities management bit, and it has relatively stable cash flows, which you can predict, and forms a very good balance to the consulting and contracting companies. And along the way, I found time to become local chairman of the Yorkshire Bank, which was part of National Australia Group at the time. It was when banks were being deregulated, and you could actually have a banking franchise even if you weren't a banker. So I decided that if you can't beat them, join them. And if I had my own banking franchise, I could lend myself money, and that'd be great. But it doesn't work like that, I'm afraid. So what have I learned in all these different things? Well, there's one quote which I'm very fond of, and the message that I would pass on to any young engineer, whether they're in industry or academia, is to be both agile and adaptable. Alvin Toffler wrote this, obviously, before the year 2000. And some recent statistics suggest that 80% of children in their first year of primary school will enter careers that don't exist now, involving technology that hasn't yet been invented. Most of my work career was involved in selling engineering and consultancy services to clients. In order to do that, you had to know as much about it as the client did, even if it was an industry which you weren't familiar with. So I had to learn about pharmaceuticals, I had to learn about coma. I had to learn about recycling and all this sort of thing in order to be able to hold my own with people who should have known a lot more about it than me. And my motto, if you like, was if you can find a person with a problem on the day they have it and convince them that you have a solution, then you had a sale. And to me, that's the art of chemical engineering, is convincing people that chemical engineering can provide a solution to their problems. So moving on, I've been involved with IChemE for many years, and it's an institution which I can honestly say I love. We've had our ups and downs, as you'll see in a minute, but I'm very fond of IChemE. I started off in the 1980s, I think about 1980 or 81, with the then Manchester and Salford Centre, part of the Northwest branch. And I went along because I was asked by one of my workmates to come along. And I think it's something that we can all do to encourage people to join IChemE, is to ask them to get involved. In the 1990s, I joined the Pharmaceutical Special Interest Group because we had a pharmaceutical business, and I decided it would be a good way to network. And I was encouraged, shall we say, to write a book about containment, which was a topic I was and am still interested in. In fact, Martin Ryder has made an entire business out of selling the equipment that we talked about in that book. In the early 1990s up to 2017, I joined the what was then the IChemE Awards, now the Global Awards, initially as a judge, and then for many years I was chair of judges, and that's me in 2005, I think it is, with that year's presenter, Mr. Johnson. You can see that it's notable for the fact I've still got hair then. But maybe since he's got time on his hands now, maybe we can encourage him back to present another set of awards. In 2018, after the EGM, I became the inaugural chair of Congress, and that's the Congress members at our first face-to-face. And you can see it's, compared to the first photograph I showed you, it's a more diverse group, people drawn from all the areas in which IChemE actually operates. And Rob Peeling and Elizabeth Salter, who are the current chair and vice chair of Congress, are doing a great job in continuing to develop that as an important source of advice to the Board of Trustees. In 2019, Stephen Richardson, who was then president, invited me to join the Centenary Project, and my group did we call services and platforms. We produced the website and organised the events that went along with that, and the rest, as they say, is history. These volunteering opportunities I've found immensely satisfying. I've met some great people, and without the support of volunteers, IChemE would simply cease to exist. IChemE has approximately 3,000 volunteers. If they each gave 1 hour a week for 50 weeks a year, and we valued their time at, say, £100 an hour, which is the charge-out rate of a decent senior engineer these days, that's a benefit to IChemE of about £15 million per annum. Volunteers are our treasure, and we need to use them wisely for the advancement of the institution. So that's a bit about me. I want to talk a bit about chemical engineering, the profession as a whole, and then a bit about what we're doing in the institution at the moment. The centenary project was, I think, a valuable tool in setting the path for the future. Someone once said, to look far into the future, you must first look into the past. And all this was done during the pandemic years, so it was done virtually. It was all produced by volunteers, and we spent 25% of the time on the past, 25% of the time on the present, but 50% of the effort went into trying to look into the future. And we organised two celebrity lectures, one from Ken, who's in the audience tonight, and one from Adisa. And these were two topics which I chose as being of significance because the average person in the street can relate to this. If you wanted to explain what chemical engineering was in one sentence, you could talk about process safety or sustainability or both. And these were great talks. They're still on the website. The website will be there hopefully for many years to come, and I do commend them to you. After Grenfell, it was clear that other institutions could benefit from the learning which chemical engineers have developed over the last 50 or so years in terms of process safety. Roger started his presidential year off, I think, 5 days after the Flixborough disaster, which is something that none of us want to see happen again. Adisa talked about sustainability, and she talked about wicked problems, wicked being a technical term. And it describes a problem where there are many competing and conflicting aspects to it, where there's no obvious stopping rule. You don't know if you've solved it or not, and you can't pilot the results or you can't pilot the solution before you get the results. And it applies to many of the grand challenges which we see in the world today. And I think in both these areas, chemical engineering has got something to speak to the world about, and we must take that opportunity. Out of this project came a recognition that the UN Sustainable Development Goals is the vocabulary, if you like, that people are using to describe the grand challenges. And they're all on there, you can see. Chemical engineers have most to contribute to those. And in case you can't read it, we've just written them out in a bit more detail there. I'll not read them out, you can read them yourself. But that is now guiding our technical roadmap, if you like, for the future. And I think you'll be able to see how the institution is adapting and being agile in responding to these challenges. David had a very successful presidential year, and the thing that I remember him saying was think ethics before action. There's quite a lot of work to do, I think, David, in actually, what does it mean? Where do we go? How do we do it? And I am looking to try and embed that and develop it as we go along. And I think, probably less well known, but just as important is your work on improving and developing industrial academic cooperation, which is something, again, that's been neglected over the years. So I think that both of those things are going to develop in the next few years. So what about artificial intelligence? It's in the news at the moment. I'm not an expert on it. It was spoken eloquently about by John McGahn in his presidential address some years ago. Incidentally, John's just been made a member of the Order of Australia in the King's birthday honours list. So if you're watching, John, on behalf of the institution, we extend our warmest congratulations to you. But will AI be good or bad for the profession? Well, it will probably be both, but not necessarily in equal measure and not at the same time. Geoffrey Hinton, one of the major players in the development of AI, has recently resigned his role at Google so he can speak out about the dangers of machine intelligence. And he said in a recent interview that he regretted his work. Well, I can honestly say I've never regretted a day of my chemical engineering life, so I've got one up on him. I'm not concerned, personally, I'm not concerned too much about the Armageddon prophecies that we hear about. Human beings have proved themselves remarkably adept at killing one another at scale. However, I am concerned about the effects of misinformation and disinformation. They are different. I always remember it as misinformation is a mistake, disinformation is dishonest. And there's a new book I've been reading called Foolproof by Professor Sander van der Linden of Cambridge, who talks about inoculating ourselves against the virus of disinformation and misinformation. It's a very interesting concept. But as far as IChemE is concerned, I think that everything we do should be properly peer-reviewed, it should be balanced, and it's the responsibility of all engineers to be a trusted source of factual information. When I was preparing this, I was sitting next to past President Jane Cutter, who's cycled all the way here from John O'Groats. Well, not quite. She cycled from Land's End to John O'Groats and came here under her own steam. Thank you for being here, Jane. But we sat together in Rugby, and Jane started to write a presidential address using ChatGPT. It's great. You can feed all the words in: sustainable, ethical, chemical engineering, this sort of thing. And it produced a wonderful speech. It looked great until you read it. And it was entirely vacuous. You know, it said everything and it said nothing. Maybe you think I'm using that speech now, I don't know. But something that, you know, quality of information is something we should all concentrate on. I was particularly touched by something that the King said recently, which was, I think, remarkably generous to engineers. And I often think that he values engineers probably rather more than we value ourselves. His father, the Duke of Edinburgh, was our patron for many years, and I was at the 75th anniversary dinner at the Savoy when he gave a fantastic speech. We're currently patronless, and one of the challenges for Yvonne is to get the King to become our new patron. Maybe we can do that. So, where are we going with IChemE? Well, I just wanted to share a few thoughts. Now, these are my personal things that I would like to see happen. Chatham House rules apply here. This is not something which is in the strategy. These are things which are being talked about, but these are my favourites. So if we look at collaboration for a minute, I want to work with partners to get our voice heard. John Donne, the poet, famously wrote, "No man is an island, entire of itself. Every man is a piece of the continent, a part of the main." and so it is with IChemE. The Royal Academy, of course, has access to government on behalf of all the institutions, but I believe there's a need to share the unique voice of chemical engineering more widely. And I think by working with other institutions, partnering up for different projects at different times, proving ourselves agile and adaptable, we'll be able to get a better hearing for chemical engineers, and to persuade people that we can help the world solve the grand challenges. We've recently signed a letter of intent with the American Institute. Initially, it's based around hydrogen, but it's intended to be open-ended. The Americans are going big into hydrogen because it's simply not feasible to put battery charging equipment all over the wide spaces. So they're going to have hydrogen. There's 80 major companies, including a lot of the car companies, involved in the same collaboration, and we'll see where that takes us. But that's a starter for 10. I'm meeting with IChemE and the Chemical Industries Association next week to see if we've other common messages and common goals that we can promote. And if there's anybody representing other institutions here tonight, I invite you to contact me if you think we can work together to a greater end. And you can expect to see more approaches to government departments promoting our unique set of chemical engineering skills. Many of the people we meet in government are not interested in science. A degree in PPE from Oxford does not really equip you for that. The art of chemical engineering is to persuade such people without resorting to mathematics, because they simply don't understand the language. Continuous learning. I think we've got to constantly look at ways of supporting the professional development of members at all stages of their careers, and more work will be done to focus on this in the future. David talked a bit about the Sustainability Hub, generously supported by past President Ian Shott, providing a growing number of free for members courses. And we have a treasure chest of past seminars and presentations from the special interest groups and member groups, which I would like to see more readily available. We're going to be expanding our mentoring offer. We know that there's great support that volunteer mentors provide to those wishing to become registered. But we want to expand that ability to offer and provide assistance to more members who simply want some support or other career advice. Difficult for young engineers to get the sort of training that I enjoyed when I was younger. Community. IChemE was founded as a community of and for people involved in chemical and process engineering, and that's still the core of our being. But now that's a global community, and we gain so much from interacting together. We're helped, of course, by the new technologies of video calling and where we can do face-to-face. And I'm committed to developing the worldwide IChemE community so that we can support each other better. The pandemic, of course, has turbocharged the use of things like Teams and Zoom, and it's now possible for all member groups and special subject interest groups to have a more inclusive offering to people based in other countries. And, members in Australia, New Zealand, Malaysia, and indeed across the world should be able to access our services without location being a barrier. We're going to launch in the coming year a new global digital community. Members will be able to sign up to groups and topics which interest them, including some of the things I've already talked about. We're going to be refreshing the website, initially just a new front end, but you can, over the next year or so, we'll be developing that to be more user-friendly and more useful to members. And just to mention again the work of volunteers, I've already illustrated a guess at the value of the work, but I wanted to say to all volunteers in IChemE a huge thank you for all your efforts, especially over the pandemic years. Immense effort has gone into carrying on the good work of the IChemE, and we're going to introduce some digital certificates to thank you for the efforts you've made and the impact that you've had. I'm also keen to reinvigorate some of the membership categories that we might have neglected, such as technician and associate, and help more people from all backgrounds to access the opportunities that chemical engineering can lead to. Our chartered grades are, of course, rightly well regulated, and always we must maintain standards. But we need to be welcoming to people who may not have been to an accredited university or something like that. And maybe we can invent or adapt, I should say, a refer a friend scheme. The aeronauticals do this, and it would help if somebody recommended a non-member to join in one of these associate categories, maybe to bring them into the fraternity. And lastly, choice. For me, one of the defining features of chemical engineering education is that it gives you choice. I've been able to work in a wide variety of industries. It's led me to a rewarding and exciting career, which has been valuable to the economy and to society. And I want that to be experienced by many more people. I'd love to see the Why Not ChemEng scheme reinvigorated. We're collaborating with heads of chemical engineering both in the UK and Australasia on bringing young people in, but we need to do more in that area. We want to work with university departments to show that chemical engineering is a desirable career which can have world-changing, world-bettering consequences. And for those people who work in industries which are in perhaps decline, such as oil and gas, they've got transferable skills. Nothing which chemical engineers have learned over the last 100 years is irrelevant anymore. It's always adaptable to new situations. And the pace of change is such that none of us can stand still, and who would want to? So let me just finish with my definition of the art of chemical engineering is to persuade those outside the profession of the unique and priceless contribution that chemical engineers can make to solving the world's grand challenges. So do keep in touch. I'll be delighted to hear from you. Next month I'll have had 50 more good ideas, so nothing's going to stand still. But I do thank you for your interest and time this evening, and it's been a great pleasure to share these thoughts with you. Thank you.